Just a quick video tutorial in response to a Reddit user's post. They're asking, they're curious how to go about using a LAN pattern like this for a FPC connector in this case, where there is a functional aspect to the dimension of the connector. So this is a 40-pin FPC connector in this user's case, I believe. So there's very clearly not 40 pins here, but how to use this table in conjunction with this generic footprint to generate a specific footprint for that component. So I'm going to be using Altium to produce this, but I imagine I think the user was using KiCad. A lot of the same principles are going to be transferable. It's not, when it comes down to making a footprint, the EDA tool itself is not going to change the process. So to start with, let's get stuck into it. And I like to start with the actual footprint. Where the pins themselves are going. There's usually a datum point on some footprints, so you'll have a reference that everything's based off of. This doesn't appear to have it, so pin 1 is as good a place to start as any. So we're just going to go place a pad, and we're going to change this to rectangular, and we can see here that it's a 1.2 by 0.3 millimeter pad. So in the X we're going to go 0.3 and 1.2 millimeters in the Y, and we do not have a multi-layer pad in this case. It's just a surface mount. So we're going to set the offset to 1, and we're going to paste it here. So that's our first point. Now I'm going to be using a feature that's specific to Altium in this case, which is something called paste array. So you can actually copy one pad, and then through the edit menu you go paste special, paste array, and we want 40 of these, incrementing by 1, linear, and we just want to paste in the X direction. Now what's our pin pitch? We can check that here, which is 0.5 plus or minus 0.05, so we're just going to use the nominal tolerance, 0.5 millimeter pitch connector, pin pitch connector, and click OK, and then this is our reference point where we're starting from, and then just click and bam, we have 40 of our pins. Now if you don't have this feature built into KiCad or Eagle or whatever the user was producing this in, another way you can do this is by adjusting the grid size. So if you go bring up the snap grid, if you set the snap grid to your pitch, which was 0.5 through here, you can place your next pad. So we'll just go place pad again, and you can see that our, well, not immediately visible on this registration, but on this resolution rather, but there is a 2 there. So then you can see that it's snapping to 0.5 away from the first pad. You can just continue through clicking like this until you get up to 40. So you can see we've gotten up to 5 there. So I'm just going to revert back to what we did with the array paste. So now that we've got this the pin array done, all we're going to do is next we'll focus on the surface mount weld tabs on the sides of the connectors. Those are the only 2 features left that we need to do here. So what we'll do is we'll place the pad down first for the new one, and we can see, I'm just going to call this mounting hardware as a designate. You can call it whatever you want. We can see that this one's 1.8 by 2 millimeters. So there's our pad. Now there's a variety of ways that you can do this. You can set up your snap grid so it's in the same reference point as the pin, as what's being drawn here, which is 4.75 down and 2.55 to the left. In my case, I like to just do a little bit of math to calculate exactly how what the center to center distance is. So we can see here that the vertical height of this pad is 1.2, so halfway down would be 0.6. So we'll subtract 0.6 from this 4.75, which gives us 4.15 from the center of this pad to the bottom of this edge. Then we have another 2mm height here for this pad, so halfway up is 1. So what did we have? We had 4.15. Subtracting an additional 1, we get 3.15. So all we're going to do is going to go move, selection, so we already know to the left we're going to go negative 2.55, and down we're going to go 3.15, and that has put our weld tab pad in the correct location. Last thing that we do is we can just copy that now with reference to the pin 1, and because we know that this is a symmetrical connector, we can move to the final pad, paste it, and then just flip it in the X direction, and then paste with respect to that, and there's our finished footprint. You can add your 3D models and all of your component courtyards and body outlines and whatever else you need to this. It does look like they provide the offsets for those, so they tell you that this wing, for instance, is 0.8mm and the inside edge of the connector is 1.2. So in conjunction with the footprint of the connector itself, you can use that to register a 3D model if you wish, but I'm not going to go into that sort of detail on this tutorial. Anyway, keep it short. Thanks very much.